The first water pollution control facility, located at the present site of Jiffy Lube on South Duff, was placed in service in 1904. That treatment plant and an earlier one, built on the Iowa State campus in 1898, were both designed by Anson Marston, the first dean of engineering. The campus facility was the first secondary treatment plant built west of the Mississippi River. In 1922, Ames built a new plant on Oak Street, just south of the present Department of Transportation complex. The university also built a new plant northeast of the campus at about the same time. The third facility, designed to serve the entire Ames and ISU community, was completed in 1950 at a site then far outside the city limits, east of Duff Avenue and south of the present Highway 30. Detailed design of the existing treatment facility began in June 1984. Because federal grants were allocated to Ames only 1 year at a time, it was necessary to prepare drawings and specifications for 3 separate but coordinated segments of the treatment plant. This presented an unusual challenge in both design and construction. Construction of the 3 segments was completed in April of 1989, May of 1989, and April of 1990. The 4.1-mile interceptor sewer from the 1950 facility to the new plant site was built during the winter of 1986 and 87. The outfall sewer from the new facility to the Skunk River was built in the fall of 1987. In October 1989, the operating staff began a well-planned gradual transfer of load to the new facility. By November 4th, the old plant was providing only primary settling. Early in the morning of November 16, 1989, the old facility was bypassed completely, and the new facility began full operation. On your screen, you can see an updated Ames wastewater treatment process diagram. Next, we're going to walk you through each stage of the treatment process. The water pollution control facility occupies 25 acres, and the site can accommodate 100% expansion of the plant, which should serve the city of Ames well into the future. The Ames Water Pollution Control Facility utilizes both physical and biological treatment methods to substantially reduce organic materials, oxygen demand, solids, and ammonia before discharging treated effluent to the South Skunk River. The design criteria for the treatment facility is as follows. The average dry weather flow is 8.6 million gallons per day. The average wet weather flow is 12.1 million gallons per day. The maximum day flow is 20.4 million gallons per day. The maximum capacity of biological oxygen demand is 16,150 pounds per day. The total suspended solids is 16,150 pounds per day. And ammonia nitrogen coming in capacity is 2,725 pounds per day. Our discharge permit limits allow us to discharge 20 milligrams per liter of biochemical oxygen demand, 30 milligrams a liter of total suspended solids, and the ammonia nitrogen levels vary month to month, with a minimum of 1 milligram per liter up to a maximum of 5.7 milligrams per liter. Dissolved oxygen, the minimum amount is 5 milligrams per liter, but is often higher than that amount. Raw wastewater arrives at the treatment facility via a 60-inch and then to a 66-inch interceptor sewer. Flows in excess of the maximum design capacity will be pumped to the 2 equalization basins. After peak flows have subsided, this stored flow will be returned to the plant for treatment. Preliminary treatment begins with screening. Mechanically cleaned screens remove rags, sticks, plastics, and similar materials from the wastewater. These materials are fed into grinders, which shred the screenings and return them to the flow for subsequent treatment. Following screening, the flow enters the raw wastewater pumping station. 6 vertical turbine solids handling pumps deliver the raw wastewater to grit removal units in the same building. Each of the 6 pumps has a capacity of 5,500 gallons per minute. Sand, coffee grounds, eggshells, bone chips, and similar materials which comprise grit are removed here in the grit removal units. These materials are mixed with lime and spread on agricultural land. The raw wastewater then flows by gravity to the trickling filter pump station. Here, the 4 first-stage pumps lift the wastewater to the 4 primary clarifiers. These 70-foot diameter clarifiers provide a quiescent condition in which suspended solids can settle out. The settled sludge is pumped to the digester complex for treatment. From the primary clarifiers, wastewater flows by gravity to the first stage trickling filters. This is the first step in the microbiological treatment phase. The 80-foot diameter towers are filled with plastic media which provide extensive surface area on which microorganisms attach, grow, and decompose the dissolved organic matter in the wastewater. These microorganisms feed on dissolved organic matter as the wastewater slowly trickles down the 26-foot depth of media. From the first stage trickling filters, there is gravity flow to the solids contact aeration basins. This phase could also be described as a short-term activated sludge process. Because of the continuous return of settled solids and microorganisms, the appearance of these units is strikingly different from other process steps. Mixing and needed oxygen are supplied by 3 centrifugal blowers and fine bubble diffusers. The Ames facility was the first plant in the United States specifically designed for nitrification, or ammonia removal, in the solids contact basins. Flow continues by gravity to the 2 100-foot diameter intermediate clarifiers. These units are specifically designed for removing very fine, light particles, leaving the solids contact phase. Most of this activated sludge is continuously recycled back to the solids contact basin by 3 screw pumps. Intermediate settled sludge, which is not recycled, is returned for resettling with the raw sludge in the primary clarifiers. Wastewater from the intermediate clarifiers flows back by gravity to the trickling filter pump station and is then lifted to the second stage trickling filters. The microorganisms in the second stage towers reduce the ammonia by converting the nitrogenous materials remaining at this point. Wastewater leaving the second stage trickling filters flows by gravity to the 2 100-foot diameter final clarifiers. These units are identical to the intermediate clarifiers and can be used interchangeably. The very small amount of solids remaining to be captured in the final clarifiers is also returned for resettling with raw sludge in the primary clarifiers. The Iowa DNR confirmed a Class A1 recreational use designation for the segment of the South Skunk River the plant discharges to. This means there's primary contact recreation such as swimming, skiing, and diving, and considerable risk for ingesting large quantities of water. As a result, the city completed construction of an ultraviolet disinfection system in 2014. The UV system must meet seasonal in-stream water quality standards for E. coli from March 15th through November 15th of each year. The clear treated effluent flows down a cascade aerator as a final step before discharge. Aeration enhances the dissolved oxygen level, which is essential to fish and other aquatic life in the South Skunk River. Sludge digestion is a biological stabilization process which proceeds under a controlled temperature of 95 degrees to 100 degrees Fahrenheit. With adequate heat and mixing, anaerobic, which means without oxygen, digestion is largely completed within 15 to 20 days. The primary digesters are mixed and heated by internally mounted mixers and heat exchange units. Digested sludge is transferred to the secondary digester for storage. Further stabilization will occur with time. One byproduct of digestion is methane gas. The gas is stored under a steel gas holder cover on the secondary digester. Digested sludge, now called biosolids, is transferred to the sludge storage lagoon during times when biosolids cannot be applied to the surrounding farmland. The sludge lagoon, as well as the equalization basins, is lined with a 80 milliliter thick, high-density polyethylene liner to control leakage and protect groundwater in the area. Stabilized biosolids are applied in liquid form to nearby cropland. Land application of biosolids will normally be before planting and after harvest. The stabilized biosolids are an excellent soil conditioner, as well as a fertilizer. All the nitrogen needed for a crop can be supplied by land application of biosolids. With proper treatment and recycling to the land, biosolids become a valuable resource which is not a threat to the environment. The methane gas produced by sludge digestion is used as fuel to provide both energy and heat for plant operation. 3 engines drive electrical generators capable of providing 20% or more of the facility's power needs. Natural gas is also available as an alternative fuel. In addition to producing electricity from methane gas, these engines and their exhaust systems are equipped with a jacket cooling water heat exchange system for heat recovery. Hot water is circulated through the digesters to maintain optimum temperatures. In case of a power outage, a 2,500 horsepower diesel engine starts automatically. The 1,750 kilowatt generator connected to this standby engine supplies the power needed for operation of essential treatment processes. The treatment process and equipment are monitored at more than 400 points by computer. The computer allows the operating staff to check conditions throughout the treatment process. Some process control can also be exercised from computer terminals. The computer prepares daily and monthly reports of plant operation. The monthly report is printed on demand after laboratory analysis data have been entered and the results calculated by the computer. The laboratory is a vital part of the overall treatment process. With its state-of-the-art equipment, it is one of the largest and most modern laboratories of its type in the state of Iowa. Laboratory results provide a reliable means of continuously evaluating the effectiveness of wastewater treatment. They also help predict and prevent problems which may be developing in the treatment process. The routine analysis, among others, biochemical oxygen demand, BOD, total suspended solids, TSS, ammonia nitrogen, and acid and alkalinity, better known as pH. Sampling points include each major step in the wastewater and solid treatment processes, the South Skunk River upstream and downstream of the plant, and groundwater wells and soils in the area. The City of Ames is required by its federal discharge permit to maintain an industrial waste pretreatment program. The purpose of this program is to prevent the introduction of pollutants into the city's sewer system, which may pass through the system inadequately treated and into the South Skunk River. In addition, it is also intended to protect the physical and biological treatment processes in the plant from damage due to incompatible pollutants. The program established limits on both the concentrations and total quantity of pollutants that may be discharged into the sewer system. The program also contains provisions for monitoring such discharges and enforcing the limits when necessary.